in the product of array except self problem, the solution vector has the product of every other number except itself. So for example, 24 is 2 times 3 times 4. 12 is 1 times 3 times 4 and not 2. 8 is 4 times 1 times 2 and not 3. And 6 is 1, 2, and 3, but not 4. So, as I mentioned in the reading, the crucial thing when you're approaching these type of problems is thinking of process, not trying to map to the given incomplete solution set. So here what I've done is I've said that this output is 2 times 3 times 4, 1 times 2 times 3, 1 times 2 times 4, and 1 times 2 times 3. So once you break it down like this, the objective is to view how you can see it as a pattern. And again, students get caught up on the idea of being in order. So when you're testing, come up with outside of the box solutions. For example, here, this is an outside the box solution, but if you use it algorithmically, it'll come up with the exact same process that you get here if you have 1, 2, 3, 4, and 5. So when we're thinking of an array of 5, and this is what I mentioned in the reading, you have 1, 2, 3, 4, and 5 as the inputs. In the output, 1 has 2, 3, 4, and 5. Output 2 is 1, 3, 4, and 5. 3 has 1, 2, 4, and 5. 4 has 1, 2, 3, and 5. And 5 has 1, 2, 3, and 4. So if we look at the pattern, we can break it down by where it is that the current location is. So 1 would be over here, 2 would be here, 3 would be here, 4 would be here, and 5 would be here. So we see that there's a potential pattern. So in the approach, you do a forward iteration, you pre-populate the vector with all values of 1s, and then you calculate these values forward, and then you can calculate these values in reverse. So in the trace for the problem, consider this when thinking of a linear approach that uses dynamic programming by using previous solutions to find new ones. So here we have I1 times I2, I1 times I2 times I3, I1 times I2 times I3 times I4. So we don't need to do that multiplication over again and over again because we have values that build off of previously calculated solutions, both in forward and in reverse.